All right, well, we're going to do 3.3, completing the square. And with completing the square, really we need to know a few vocab terms. First, we need to know what a binomial is. So a binomial means two terms. Let's say I have x plus 3. We got one term, two terms. And a binomial square would mean I'd take that binomial, x plus 3, and I would square it. That would be a binomial square. And then a trinomial could be something that has three terms. For instance, x squared plus 6x plus 9. That's a trinomial. In fact, that's a perfect square trinomial because if I factor it, two things that multiply to make 9 and add to 6 are 3 and 3. So it would be x plus 3 times x plus 3, which is x plus 3 quantity squared. So that means that a perfect square trinomial, x squared plus 6x plus 9 is. So this is a perfect square trinomial because it factors to be a binomial square. So with that information, what I'm going to go ahead and do is show how we can use this information to solve equations pretty easily. So notice if I have x plus 3 quantity squared, which I had up above here, but let's set it equal to 100. Now, rather than multiplying it out and getting x squared plus 6x plus 9, and then having to figure out how to factor it or to solve it, what we could do is take the root of both sides. So I can get rid of this square by taking the square root. The square root undoes the square, so that gives me x plus 3 left on this side. And remember, whenever you impose a square root, that means you start a problem without a square root and then you put it on inside the problem. What you have to do is put that plus and minus in front. So that would mean I'd have plus minus root 100. And we know that root 100 is 10. So really, I'd have positive 10 and negative 10, or plus and minus 10. So x plus 3 equals plus minus 10. And then from there, what I could do is I could actually subtract 3 from both sides. So I'd have x is equal to negative 3 plus minus 10. And really, that means I have negative 3 plus 10. That's the plus part. And I have negative 3 minus 10. So one solution is 7. The other solution is negative 13. So x equals negative 13 and 7. I put it in set notation because there's more than one solution there. There, we've got it. That means if I put negative 13 into my original equation, negative 13 plus 3, that is negative 10 squared is 100. If I put 7 in, 7 plus 3 is 10, squared is 100. So it works out. Now notice if I actually started out with the trinomial, and I recognize that it's a perfect square trinomial, I could actually factor it in to that perfect square, or that binomial squared, and then go through the same process. So I won't bore you with that because that same process, because it's really the same thing we just did. But you know, you go from here to here by factoring. And if you know that it's a perfect square trinomial that you have right here, that makes it a lot easier. So our goal today is when completing the square, we want to be able to write a trinomial as a binomial square. Okay? The goal when completing the square is to be able to write a trinomial as a binomial square. Now I'm sorry that I've written over where that is, but I'll highlight it. That is our goal. Okay? So we want to be able to write a trinomial, this, as a binomial square, which makes it easier to solve. Okay. So I'll go through some problems like that and we'll see what it looks like. So the first thing we need to do is be able to quickly rewrite a trinomial as a binomial square. So if I have this trinomial and I want to write it as a binomial square, one thing you'll notice in that previous problem is this 3 actually comes from this 6. If you take half of 6, so I'll rewrite it here, x squared plus 6x plus 9, If I take half of that, that actually gives me that 3 right there. Okay, so that's what we end up getting. And then if I square that number, that's how I get the 9. Okay, that's kind of the pattern we end up following there. So really what I can do to find this back part is cut that in half and square it. So half of 18 is 9 and squared is 81. The way I showed in class is what I do is I say, well, I know that I'm going to take the root of this, and then if I cut this in half, that's positive 9. And then if I square that number, that gives me that number. Okay. So, for instance, if I'm trying to rewrite this trinomial as a binomial square, I'm going to take and cut that in half. It's going to give me my second term of my binomial. So that's going to be negative 12. Notice I dropped the x. Here I dropped the n. And then I'm going to square that number. Okay, negative 12 squared is 144. And the square root of x squared is x. Okay, so this becomes x minus 12 squared. That's the binomial squared. All right. And for some reason I have the same problem back here, and I have no idea why, but, you know, oops, not negative 2, but, you know, let's go ahead and just change this one here. Let's do this. That way we can have another problem where we're trying here. Let's make sure we'll go ahead and, let's just go ahead and take out that 2. All right, so let's say we have x squared minus 4x plus something. All right. And so really what that means is I take half of that 4, that negative 4. That would become my back, so that would become negative 2. Square root of this. And then if I square this, it actually becomes negative 2 squared, which is 4. Or half of this number squared, which just happens to be 4. So x minus 4x plus 4, x squared minus 4x plus 4 becomes x minus 2 quantity squared. They're the same value. If I multiply x minus 2 times x minus 2, I get x squared minus 4x plus 4. Okay, so that's a quick way on how to rewrite a perfect square trinomial as a binomial square. So let's look at this. If I can quickly test to see if something's a perfect square, I might be able to solve it. So if I want to solve this equation right here, there's a couple ways I could do it. I mean, in previous lessons we've learned to factor, we've learned to graph, but here we're going to practice completing the square. So I want to look at this problem and say, okay, if I take a squared plus 18a plus 49, first, is that a perfect square trinomial? And the way I'm going to try to check that is by what I did here. Hey, take half of it and square it. Well, oops. Half of this is 9. Squared is 81 now. Obviously, we just had that same piece on the other problem. So that's not going to work here. So this is not a perfect square trinomial here. So what I'm going to do is I'm going to rewrite it without that 49, meaning I'm going to move this 49 over to this side. Okay, I'm going to subtract 49 from both sides. So that's going to give me a squared plus 18a equals 51. All right. So now what I could do is I could fill in the back part with whatever I want. I can say, well, I know that in order for me to have a perfect square trinomial here, I need to take the square root of a squared, okay, and then take half of this, half of 18 is 9, and then square it, and that becomes my back term. Now, I added 81 here, and since I'm in an equation, whatever I do to one side, I have to do to the other. So I'm going to have to add 81 on this side as well. Okay, so I end up with a plus 9 quantity squared is equal to 51 plus 81. Well, 51 plus 81, well, 50 and 80 is 130. And, oops, 1 plus 1 is 2, so that would be 132. So from there, they can then take the square root of both sides. So I'd have a plus 9 is equal to the square root of plus minus square root of 132. Now, it's not a perfect square, so that's okay, though. Okay, so for those of you like, whoa, why did he take the square root? Remember, to undo this perfect square right here, I have to impose the root to both sides. So I have to put that plus minus. But the root cancels the square. Okay, and then I'm left with what's inside. All right, and so that last piece would be I'd subtract 9. So I get a, not 9, I get a is equal to negative 9 plus minus square root of 132. So we'll put the subtracting 9 piece right on the outside there. Okay. Now you should always try to simplify the 132, the radical. So I know some teachers maybe, well, you're just learning completing the square, so you don't have to do that, and they may accept this as an answer. I personally think that you should simplify that. So when I look at it, I go, well, what goes into 132? Well, I know 4 does. I can cut it in half twice. Half of 132 is 66. Okay, and then I can cut that in half, which gives me 33. So that means I'd have, oops, I forgot my 9 there. So let me, I'd have my 9 plus minus root 4 times root 33. Okay, so 33 times 4 is 132. And then root of 4 is actually 2. A would be equal to 9 plus minus 2 root 33. Now, you can't add the 2 and the 9 because you have to be able to multiply first, so you still would follow the order of operations. So at this point, you would be done. And there's actually 2 answers there, right? There's 9 plus 2 root 33, and there's 9 minus 2 root 33. So that's why we have in set notation there. Okay, now I won't get as elaborate in all of them and explain, but I think that was important to kind of go through. So let's go ahead and try another one here. So x squared minus 12x plus 36. Kind of hit a really tough one to begin with there, but let's look at it. First, if I take a look, if I take half of 12, that's negative, or half of negative 12, that's negative 6, and then square it, I get 36. So this is a perfect square. Okay, the square root of x squared is x. The square root of 36 is 6. And notice I'd have to take half of negative 12, so that would be negative there. You just bring this sign down. Okay, and that's equal to 25. So that's nice. This was a perfect square to begin with. Okay, half of 12 is 6. 6 squared is 36. Just like we did, remember, just like we were doing over on this page. Okay, and so from here I can just solve. I'll go ahead and take the square root of both sides, so I get x minus 6 is equal to the square root of 25. Remember, don't forget the plus minus. We then add 6 to both sides, so x is equal to 6 plus minus, and square root of 25 is 5. So really that means I have 6 plus 5, and I have 6 minus 5, which means I have a solution of 11 and 1. So x equals the set 1 and 11. Now if you're like, well, I hope I did that right, just double check it, plug x in. 1 squared is 1, minus 12 times 1 is 12, plus 36. Okay, does that equal 25? Well, 1 minus 12 is negative 11, and negative 11 plus 36 is 25. So 1 worked out. Trying 11. 11 squared is 121. Okay. 12 times 11 is 132. And plus 36, well, 121 minus 132 is negative 11. Negative 11 plus 36 is 25. That one worked out. So just check your work. A lot of times you can find out if you made a mistake and then fix it before you move on. All right, let's go ahead and try a different color here. All right, so checking it out, see if it's a perfect square trinomial. Well, x, half of 6 is 3, and 3 squared is 9. That is not 9 right there. So one way some teachers say is, oh, what do you have to add to 8 to make 9? Well, you could just add 1. So if I add 1 to this side and 1 to this side, it ends up giving me the 9 I need. So really, all of that equals 1. Now, I usually don't do it that way. I just thought this would be a good problem to show that on. So I take half of 6, which is 3, square 3, and that's 9. And I don't quite have 9. I only have 8, so I needed 1 more. And so let me fix that there. That 1 that I added right here is to get me that 9 that I need to make 3 squared. Okay. So whatever I do to one side, I have to do to the other, and then I can solve it using roots. Go x plus 3 is equal to the square root of 1 plus minus root 1. And that's just 1. So when I subtract 3 from both sides, I get negative 3 plus minus, and square root of 1 is 1, which gives me 2 answers, negative 3 plus 1 and negative 3 minus 1, or let's see, negative 3 plus 1, we got negative 2 and negative 4. So x equals negative 2 and negative 4. Usually put them in numeric order, which I should have done there, so kind of get on people about doing that. So maybe I'll fix that real quick. So negative 4 and 2. Technically, it's not wrong, but and then you could once again check it. Negative 4 squared is 16. 16 plus negative 24 is negative 8 plus 8 is 0. And negative 2 squared is 4 plus 6 times negative 2 is negative 12. So 4 plus negative 12 is negative 8, and negative 8 plus 8 is 0. So it works out. All right. So our last one on this slide, let's go ahead and check it out. I'm going to do it the way I normally would. Take the root of that, divide that in half, and then square it. Okay, well that doesn't work, so I'm going to, since that square does not equal that, I'm going to start by adding 3 to each side. That gives me 0 there, and it puts a 3 over here. Okay, and so usually I would test this just in my head and go, well, you know what? Half of 2 is 1, and 1 squared is not 3, so I know that I have n squared minus 2n is equal to 3. So I just tested out, didn't work out. So I want to figure out what I can add to the back to make this a perfect square, and I'm going to have to add that same amount over here. Okay, that is not a 0. That's something I'm going to add. So let's maybe make that a little more clear over here for us. Okay, so I'd have n squared minus 2n. We'll put plus something equals 3 plus something. All right. So kind of back to our elementary where we have the plus box, you know. Okay, and so square root of n squared is n. Half of that is negative 1. And that's the perfect square I want. Square that. I need to add 1 to this side. And I have to add that 1 to this because that's what the square of this is. And so we get 4 over here. So I now have n minus 1 is equal to plus minus root 4. N is equal to 1 plus minus square root of 4 is 2, which gives me 1 plus 2, 1 minus 2, or 3 and negative 2. So n equals the set negative 2 and 3. All right. There we got it. Let's go ahead and check out something else here. Let's solve these by completing the square. So these get a little more complex. V squared minus 6v equals negative 91. So I'm looking at it and I go, well, let's go ahead and set it up like I did the last one. 6v plus something is going to equal to negative 91 plus something. Okay, that something is whatever's going to complete the square here. So if I go v minus half of that is, half of 6 is 3 squared, and that's going to give me 9 back there. That means I have to add 9 to both sides. Well, what that does then, Negative 91 plus 9 is negative 82. I then can take the square root of both sides, plus minus the root of negative 82, negative 82, and then add 3, so b is equal to 3 plus minus the root of negative 82. Well, when I look at that, I notice that this is a negative, and that means I can take out or break it up into root negative 1 times root 82, which really is 3 plus minus root negative 1 is I, root 82. And root 82, when I think of that, no perfect squares go into it. Therefore, I am done. That's what b equals. All right. Now let's go ahead and try this one here. We're going to distribute. We're going to get 6x squared. We're going to get it into more of a standard form. Plus 30x equals negative 24. Okay. Well, anytime you have an a term out here, you want to get rid of that a term by dividing by a. Now, if a doesn't go into all three of these, I probably would never use difference of two squares to solve it. However, this case, a, 6, goes into every term. So I'm going to divide everything by 6, and that's just going to eliminate that a term. So I'm left with x squared, 5x, and negative 4. And then I'm saying, okay, if I have x squared plus 5x plus something, now I'm right into my difference of two squares, or excuse me, I'm completing the square. I'm going to see what I have to add to both sides. Okay, well, in this case I have x plus, well, notice this is kind of an ugly. Half of 5 is 2.5. Okay, that's another thing. I usually would never do completing the square if my b term's odd. Okay, just because you get a decimal or a fraction. I really don't like that. But I square 2.5. It gives me 6.25. Okay, which, you know what, I can't be confined by the box there. That's ridiculous. So unbelievable. Let's put 6.25. Okay, and then we'll put the box around it. Okay, and same thing over here. I'm sure that I can't fit it in there to make it look nice and neat. So let's go ahead and erase that, and we'll put our 6.25. So that's what we're adding to both sides, okay, to get our perfect square. All right, that gives me, 2.25. And then I want to go ahead and take the root of both sides. Okay, well, that's x plus 2.5 is equal to plus minus the root of 2.25. Well, at least the root of 2.25 is that's a perfect square. If you think 225, that's 15 times 15, so this will be 1.5. So I'll go ahead and now subtract 2.5 from both sides. I'll get negative 2.5 plus minus the square root of 2.25 is 1.5. And that means I have an answer of negative 2.5 plus 1.5 and negative 2.5 minus 1.5. Okay, which here this is negative 1, and here this is negative 4. So x equals negative 1 or negative 4 and negative 1. There, we've got it. Perfect. Holy moly. All right. Let's go ahead and try one more here. I'm going to go ahead and start by adding t squared to both sides on this one. Okay, so we'll add t squared over. We end up with, getting it in standard form, we have 2t squared plus, and we'll also add the 9t over. So add t squared, add 9t. We're going to do that on both sides. Maybe I should actually show that. Okay, so I'm going to have add t squared, add 9t. Okay, here you get 0 and 0. Here you get 2t squared and 16t minus 6 equals 0. And now I'm going to get rid of that 2, that a term again. Okay, so I'm going to divide by 2, divide every term by 2. Okay, well here it gives me t squared. Here it gives me 8 and 3 and 0. And now I'm going to go ahead and add the 3 over. So t squared plus 8t, we'll put 3 onto the other side by adding 3. And I moved it because I just know that if I cut this in half and square it, that's not going to be 3. So what I'm asking myself is t squared plus 8t plus what is going to equal 3 plus what? So I want to make that perfect square trinomial. So we'll take t, we'll take half of 8, which is 4, we'll square it, which is 16 and 16. Okay, and so that means all of that equals 19. All right, so we'll take the root, t plus 4 is equal to plus minus root 19, subtract 4, so t is equal to negative 4 plus minus root 19. And that is our solution. All right, we'll kind of separate these out here. Okay, well, there we go. There's really only one other thing we do here in this section, and that's to use completing the square to write a quadratic in vertex form. You'll notice when you're looking at this, let's see, maybe like right here, this is very close to vertex form. You have that perfect square binomial there. And so what I'm going to do in order to do that, I'm going to think of this as, well, I want to make that perfect square binomial. Okay, and so the first, so I'm looking to make that. The first thing I want to do is ask myself, well, half of 12 is 6, and is 6 squared 16. And so to give myself a little more room, I think I'll rewrite the problem over here to show what we need to do. All right. Well, since it's not half, 16 isn't half of the square, or isn't the square of half of 12, so we'd need 36. So I'm going to just move this 16 over and say, well, y minus 16 is equal to x squared minus 12x. So really, I just subtracted the 16 from both sides. I got rid of it here and here. That ended up giving me that equation. Okay, and so from there, I can ask myself, well, if I have y minus 16 equaling x squared minus 12x, what do I need to add to that 12x to make a perfect square? Okay, and I'll have to add the same thing over here. Well, really what it is half of that 12 again. Whoops. Half of that 12, which is 6, and squaring that is 36. So we'll have to add 36 to both sides, and that gives us x minus 6 quantity squared. And that's equal to y, well, y minus, well, it actually will be plus now. Negative 16 and 36 is 20. Okay? And now just to get it to vertex form, just one more step. You move that 20 back over. So you have y equals x minus 6 quantity squared minus 20. Just subtract that 20 on both sides. And notice you now have it in vertex form. Remember, vertex form is y equals a times x minus h quantity squared, all plus k. So h is 6, k is negative 20, a is 1. So we've got vertex form right there, and we are done. Good to go. All right, that's all I've got. Good lucky.